All right. Hi, everybody. I'm Asha Easton from Immerse UK. Thank you so much for joining us for our panel on the future of XR and manufacturing. As we kick off with Digital Manufacturing Week, I want to thank all of our fabulous speakers for joining us today. We have Daniel Norbury, who's project manager of Virtalis, Frank McQuade, who is the Director of Capability from Bloc Digital, and Christine Perey, who's the founder of Perey Research and Consulting, and also the founder of the area. So we're going to have each of our speakers do a 5-minute kind of introduction to who they are and what they do. And then we're going to go to some questions. I'll have some of my own to start with. And if you have any for the speakers, put them in the Q&A and we will get right to them. So to start off, I'll hand over to Daniel to do your introduction.
Good afternoon and welcome. My name is Daniel Norbury. I'm a project manager for an organisation called Virtalis. Virtalis are a visualization software development company and XR systems integrator for the manufacturing and engineering industry. What I'd like to do today is discuss what Virtalis have been doing to remove some of the blockers to ensure that manufacturing and engineering organisations are becoming successful with the use of visualization technology. So let me just share my screen. So let's just start with imagining what are the possibilities for this type of technology. What if all digital communication was done in a single 3D world? What I mean by this is, imagine all of your supply chains, all of your departments, all of your teams from around the world working together in the same place without leaving the comfort of their own home. With the ability to connect to real-time control systems and give contextual knowledge to each other and be compliant with standards and regulations. Think about what this means. Engineers can give context and share knowledge to senior executives. Supply chains can understand the requirements of OEM manufacturers and the end user. Everyone can understand what is happening in places they can't go, all because complex information is given context. Now, I think it's probably easier for yourselves to understand what Virtalis do by looking at some of the user cases of some of the major organisations that use our technology. So if we look at this offshore oil rig and subsea company who use our software, they use our technology to de-risk the activity of going out to a hazardous environment. The reason why they find this extremely valuable for their organisation is because when they do a return trip to the ocean bed, this costs hundreds of thousands of pounds a time. Not to mention if they close down an entire oil rig, which costs millions. Now, if they go out to sea and they drop a pipe into the ocean, and there's any incorrections or faults with this pipe, it's going to be extremely difficult to retrieve this from the bottom of the ocean floor. So what they do is they simulate indicate all risky scenarios in a virtual environment before they go out to sea, to ensure everything is in order and to ensure that the engineers have access to what they need to have access to. You look at another one of our organisations, BAE Systems. They manufacture subs and ships. Now, they've quoted that our technology, our visualization technology, is the only technology that they can find that can render an entire ship all in one scene. The reason why this is important to them is because BAE Systems have a requirement to have teams of engineers to be aligned with customers, suppliers who are located all around the world. They need to be able to import data quickly on a daily basis, and no matter how large it is as well, within minutes, to ensure that a collaborative design review process is happening in real time. They require an enterprise solution which supports multiple endpoints across the world also, and can connect at least 3 systems together. to ensure that these remote teams can all collaborate together in the same virtual environment. Their systems need to stream and connect real-time data so they can develop a digital twin for this data and have connectivity to real operations. So if we look at the general communication challenges of our organisation, you may have seen this type of methodology before, the people process technology methodology system. Some of the communication challenges associated with each of these different themes are some of the types of challenges which Virtalis focus on and removing blockers and removing barriers for. If you look at the communication challenges of people, they have different languages, they may come from different backgrounds, they may have different skills. When they're all needing to align and communicate together, this can lead to extended meetings, can lead to inaccurate information being transferred, and misunderstandings. If you look at the communication of processes, teams of people all around the world need to have access to complex supply chains. They need to understand what is happening in hazardous environments, while also being compliant with standards and regulations. The general technology the organisations are using currently, involve countless spreadsheets, PowerPoints, 2D drawings, PLM, all of which are contextually separate from the activities, the operational activities at hand. So what have Virtalis been doing? Well, we've got some exciting. We've developed a visualization platform, a new cloud visualization platform, which will allow users to access 3D visualizations from anywhere in the world on any device they like. And we've called this Virtalis Reach. Now what this means is you can now have enterprise scale visualizations of hundreds of gigabytes in size, similar to what BAE Systems and our subsea organizations use. You can now have access to this on any device you like. You can use PCs, you can use laptops, you can use mobile phones. You can also connect it to XR endpoints as well, such as a VR head-mounted device or an AR head-mounted device, all of which can be connected to the same scene. And the way we do that is we calculate the processing. The majority of the processing power is calculated on edge servers. Now, another benefit behind this type of methodology is nothing is installed and nothing is downloaded onto the user's device, which means that all of the data is safely secure wherever it's been saved in the organization's head HQ. We've also partnered with organizations, organizations such as Siemens and PTC, so we can interface with their PLM technology. Now this removes the human error factor by automating a lot of the administration tasks to ensure that meetings are auditable, and truly supporting export control requirements for it to be a worldwide enterprise collaboration platform. Virtalis is proud to work with major industry leaders, and I'd like to thank you for listening to this presentation today. If you'd like to know more about our technology or systems, please reach out to me, and I'll happily discuss it with you.
Yes, so we are a graphic artist, software engineering company based in Derby. We've been running now for around 20 years. We grew out of Rolls-Royce originally. So originally we were around the marketing and the digital technical aspects of Rolls-Royce's products. In the past 5 years, with the advent of XR, we've grown, and now we service many different organizations. We're still an SME, but we're actually dealing with a lot of use cases and a lot of different information types in engineering, and mainly that's our specialities around engineering and technology. And we merge engineering, manufacturing, software engineering, graphic artists, those types of skills. I joined the company 2 years ago. My background is I'm an aeronautical engineer. I worked in the space business for 15 years. For the last 10 years, I was the head of engineering strategy at Rolls-Royce. And then I joined Bloc 2 years ago, as I say, the director of capability. What I've got on the screen here at the moment is just different examples of XR that we've implemented. So these are solutions that we've provided. The one that I've highlighted now there on the top left is for a well-known pharmaceutical company, and we've got an AR type capability there where someone with a headset can go and actually look at machinery. They can understand any issues, any faults with them. Essentially, I like to say we take the photocopier model where you can actually follow, open panel A, turn lever B, that type of simplicity when you approach maintenance. The next example here is an example we did for Rolls-Royce, actually. It's been in the news. This is how to strip and prepare a gas turbine for travel. It's got over 500 individual training steps in there. So that was done. That's been very successful in reducing the training burden in Rolls-Royce, especially when they're such a global company. And the one on the right, again, it is a Rolls-Royce activity where this is a mixed reality object where we've taken a completely virtual digital twin, and what we've done is we've placed that in someone's view. And you might ask, what's the use of that? Well, the next one here in the bottom left is an interesting use case. What that is a system from a Rolls-Royce gas turbine, and what we have done, that's actually constructed of images that service engineers and manufacturing engineers have taken on their mobile phone. So they've taken a mobile phone picture of some damage, inspected the whole components and systems, and then we've merged them back together to give people back at base an augmented reality view of that, and they can see the whole and advise people who are on the shop floor. And talking of shop floor, again, this is another pharmaceutical system here. What we've got is a production line, and what we've implemented here is a virtual reality version of that production line. And what it allows people to do is to train on that production line without actually taking the real system offline. As a consequence of that, the downtime of that production line has gone from around about 1 day a month to actually half a day a month. So it has been a massive financial benefit there to the customer in reducing and maximizing productivity. Last example here is a high fidelity digital twin of a real component. So this is a BMW differential. We tend to get things arriving in the post, odd things like engines from a Bugatti, and we get asked, can we make a digital twin of that shows how the system has worn and how is it degraded over time, and we'll get sets of pistons, etc. So that was just a quick overview of the type of solutions we do, the type of solutions that we often encounter, and I would suggest very much it's really around aiding people to understand what they're dealing with, what they're around, and how information flows through their systems. So that's me.
Excellent. Thank you, Frank. It seems we have Daniel has dropped off for a minute, so we'll continue with Christine, and then we'll hope for him back in the meantime. Hi, Christine. Welcome.
Hi, Asha. Hi, everybody. Thanks for having me. Yes, I'm an independent consultant. I do research, and I've been studying augmented reality since 2006. For many of those years, the first 5 or so, we all thought this was going to be an extension of the smartphone that would take off in consumer environments. But I had an opportunity to be in a room full of very, very interested enterprise engineers who were interested in using augmented reality for maintenance, manufacturing, logistics, and so forth. That was late 2010, early 2011. And it just dawned on me that enterprise and industrial use cases would be the killer apps, perhaps, for augmented reality. I've never studied virtual reality. Many people make this journey from VR to AR. I went from mobile computing and other sensor environments and dynamic real-time communications into augmented reality. And I very, very much appreciate how the journey from VR to AR can be challenging when you have been working entirely in synthetic environments, and all of a sudden you have this very chaotic real world. And in fact, it's the challenges of the real world that interest me most. And some of my clients and colleagues in the industry, we formed the AR for Enterprise Alliance back in 2013. And we did that because the use cases that these companies were facing were so different than use cases in entertainment or marketing and retail, where we did see many opportunities, but there were so many factors that were different in industrial use cases. And many of the use cases and the industries, the people from these customer and integrators who have joined the area focus on enterprise and specifically in the manufacturing domain. And of course, it's logical because of the extension of all the CAD and CAM graphics that these companies already own, and they want to take from the design and engineering of their products through to the assembly, packaging, and finally the delivery to their customers. So it's really a natural evolution. I also think that it's really important when people get into this field to make a clear distinction between when do you need the physical world to be part of this experience, and when can a completely synthetic environment meet all of your requirements. I work with a lot of companies to define their requirements, to better understand their use cases, help them to find the risk reward, the balance between when they need a fully digital or a fully synthetic environment versus when they have to go into the physical world. Many companies don't have the perfect maps, the 3D models of their plants. They may have had some simulations, but they don't have the real world mapped in 3D. And that's where I've been working a lot now in the last couple of years, is in mapping the 3D spaces and putting that information into the cloud or at the edge of the network so that it's not burdening the device that the person uses when they're displaying their AR experiences. We call that the AR cloud. And there's a lot of exciting advancements that have been made in that area, even in 2020 and these unusual times. So AR cloud is something I'm very passionate about, and I think it's going to be highly relevant for manufacturing facilities and the people in them.
That's a good segue actually into my first question, really, which is what are the most significant trends you both have seen in the last, especially 1 to 2 years, I'd say. I feel like we're at a bit of an inflection point with this technology. What have you guys been seeing happening?
For me personally, that's it, the complete mapping and continuous mapping, because it's not enough to just say, oh, I mapped this last week or last year. You do need to have this continuously updated digital representation of the physical world, and to have your AR attached to that digital representation of the physical world reduces the overhead on the developer, on the device, and then on the human, of course.
I would second that. Actually, from my perspective, I think, Christine, you're absolutely spot on. I will say that maybe one thing that's a slight extrapolation is that I've seen a lot more pressure on time and cost of development. It's really in this point, Christine, that you raise around closed loop development. But when we were developing solutions 3-4 years ago, they were high value capital equipment, and there was a lot of time and effort went into that. Now people want to use it to bridge gaps in their value chain. And so it's very much smaller scope or cost implementation. So it's actually becoming more efficient as an industry developing these types of solutions.
Right, and I think that you're bringing up a good point in terms of how people measure their success, right? Efficiencies. Another way that we're seeing a lot of more activity this year, and it's really come into focus, is risk reduction. Risk to materials, risk to property in the factories, and reduced risk, so for safety, right? And safety, being able to guide a worker through a facility they may not be familiar with, or maybe they're familiar with it, but things have changed, and to guide them through their tasks without them having the possibility of being hit by a robot or getting in the way of some other machinery that's in the environment. So safety has become a very, very big driver. It's something that people are optimizing for now in the factory using AR.
That's really interesting. And on that, I'm curious for both of you, what kind of, well, especially like Frank, as you're deploying solutions, what kind of hardware you're using, and you know, where would you both like to see improvements? I know we kind of spoke, Frank, before about, you said the HoloLens 2 wasn't as robust as you'd hoped, for example. But where would you like to see improvements?
I will caveat that by saying I think the HoloLens 2 is a very good device. And
I don't mean to call you out on that.
But actually, I think, again, Christine, I think what you say there around health and safety, we have large organizations that their health and safety precludes them from actually deploying equipment. Here at Bloc, we are tool agnostic. So we have deployed Virtalis solutions. We deploy, you know, Oculus Quests or HTC Vives or whatever. It's really depend on the customer's needs and the customer's requirements. We're flexible to that. But again, it's the robustness. I think one thing that I maybe more projecting forward a little bit, one of the things we'll tend to see is lighter devices, devices that are more health and safety conscious. And I think from that, then we'll start to see some clear winners and some critical killer apps emerging, as I say, in the enterprise space.
I might just raise Anita. People have mentioned in the chat that they can't see Frank speaking, or they can't see him in full screen when he speaks. I don't know if that's something you can work on. Okay, there's Asha.
If you click up in the top right where it says view, guys, you can click speaker or gallery. If you click gallery, you'll be able to see all of us speaking at the same time.
Perfect.
It should be in the top right corner.
So on the subject of what hardware people are using, it's true that in AR, there are fewer options, and people are really gravitating and have gravitated for a long time to the HoloLens platform. Having said that, many companies can't afford or don't want to invest in a platform that they don't feel is mature. And so what I see a lot of, and what I advise my clients to do, is to use a tablet as a surrogate for when you have the right wearable device in the future. So on the hardware, I basically say, sure, get one of everything, put it in your lab and try it out. But don't let that stop you. And you should continue to invest in your infrastructure, in better understanding the user interfaces and user experience, the tools that you need to integrate this into your manufacturing environment management systems. And if you get fixated on the device, you're going to be frustrated because no device is perfect. And there's so many use cases, there's so many personal preferences. Some people will want a monocular because it's lighter, because they don't want that level of immersion. They want just the information they need to have when they need it. The drawback, of course, of a tablet is you need to have your hands free to do other things. And so people have worked out ways of carrying tablets, of supporting them in a brace, or you know, just not being able to implement this in a complete way because of the lack of maturity of the head-worn displays. The point that Frank made about lighter devices is really important. You hardly ever hear people talk about power consumption anymore. Remember, Frank, you know, 5 years ago or 3 years ago, it was like, oh man, I could only use this for like a half an hour or 2 hours. It's amazing how much processing power this takes. And so the batteries would just run out. I mean, absolutely unscalable, a game, it's not good. Now we know that the processors are more efficient, they take less energy. So we don't hear about that as much, but we still do hear people feeling it's awkward to wear a computer on their skulls. And so that's really going to take a long time to get to the optics being light, to having a bigger field of view, and so on. There's a lot of innovation, but it's still going to take a long time.
Can I add to that? So I think that's a really good point. One of the areas that, as you say there, Christine, about, you know, you're almost planning for the future. In terms of our own Bloc digital research, what we have is actually 3 KTP associates. And what we've done is actually invested a KTP program, one in process, one in data, and one in...
Can I jump in and just ask you to explain what a KTP is? A knowledge transfer partnership for anyone who doesn't know.
It's a knowledge transfer partnership where we partner with a university, and the university helps transfer knowledge that they have via a researcher into a business. So it tends to be, we put in a certain amount of money, the university supplies the staff, and the government KTN provides funding. So what we've done, we found this to be tremendously helpful. And what we do is we have a KTP associate who is looking at capturing process, one at data and one at geometry. And so what we've actually, because of that, we've found ourselves in a situation where we can capture the information once, and then in a touch of a button, we can deploy it to a tablet or a HTC Vive or an AR environment or a mobile phone or a laptop. And it's just that fact that we recognize, just to emphasize Christine's point, we recognize that it's such an evolving world, but the information, this data lake that surrounds it can be constant and alive and updating. You know, I don't want to...
Yeah,
that's really interesting.
I think that one of the important things too about the devices, if you still want to stay on the subject of hardware, is that we are getting to the point where many wearable device manufacturers are adopting and implementing the OpenXR protocol. So that OpenXR protocol from Kronos Group is very important because it creates a middleware layer. It's an API to the hardware. And so regardless of what tool people have used to develop their AR applications or their VR applications, as long as the OpenXR layer is there, they won't have to get into the optimizations for different hardware components. And they'll be able to take advantage of what the hardware offers without extra investment. So that builds in some flexibility and some resilience in terms of the applications and the investment you've already made. If you go with OpenXR compliant hardware in the future, you're safer. So that's one of the ways of reducing the transition costs, or maintaining a very heterogeneous hardware environment, because you really do need that. You shouldn't lock in on just one supplier or one platform.
That's really interesting. I hope I got the link right there.
did,
I just wanted
you
to
did.
Googled it really quickly because I've actually not heard of this before. It looks really, really interesting. Is this something that you use then when you're working with clients to help
Well,
with their,
so I've been advocating for interoperability for much too long, longer than it's been popular, is what I mean to say. The Kronos Group does some excellent work, particularly at the hardware layer or the software layer just above, to give access to the hardware in these devices. But it's not the only standards body that's working in these fields and making some excellent headway. The other standards organization that is most people recognize is the W3C. And the idea there for the past, I think it's three years this month, we're celebrating the 3rd anniversary of WebXR. And there the goal is to make many of the underlying technologies on the device accessible through a web browser with all of the inherent protection and privacy and the benefits of using a web browser and getting access to these specialized accelerator, hardware, but also cameras and other sensors. So WebXR is another it's relatively early in its maturity, but it's exciting because it's being co-developed by all of the companies that provide you your web browser. So you don't have to wait. They will not like have a big party and get all excited. They're just implementing this WebXR protocol gradually in every release of their browsers. So behind the scenes, while we weren't watching, our browsers are getting more and more XR friendly. Now, the big stumbling block is that when you turn on the camera in a web browser, the user's environment and so much about the user's personal information could be exposed to applications that are in the browser or that are using the browser code. So there's been some delays and we haven't implemented all that we would like for natural feature tracking for understanding the real world in WebXR. It's still very, very focused on VR.
With all of these advancements in interoperability, the hardware is moving really quickly. All of these solutions are moving really rapidly. I have questions around security and whether or not you're seeing pushback still from corporations that are worried about security problems, or if you feel like there's a bit more of a warming to this, or if they feel like it's robust enough, the security solutions, or not.
I think that's a really good point, Asha. I think the one thing I will say is that we've advanced to the point where IT security organizations will treat XR with the same level of contempt as anything else. It's now to the point that we're on an equal footing and we have to justify ourselves, and
that's good.
That's a good thing. We're not special. We're not a special IT case anymore.
I agree in the sense that many security professionals are more aware of what VR and AR do, and that these systems, that's another good reason to keep a little bit of a professional distance from the newest parts of hardware segment, is there could be malicious code there could be corporate espionage or whatever, things that security professionals do worry about. In the area, one of our very first area bespoke research projects, in fact, the first one, was on the subject of security. It was 3.5 years ago. And so we asked a team to examine IoT security, other networking security, mobile device security, and to look at all these frameworks that already existed and do exist today for protecting personal and corporate data, and to extend those frameworks and to help our members understand how to manage this extra layer as not really a separate security challenge, but part of your existing data environment. So we've just done an update on that, and we've developed and published a very nice figure about security concerns. There are some that are personal, there's some that are corporate, there's some coming from the hardware, from the data, from the network. And so putting it visually before people so that they can better segment the problem and target specific zones of concern.
Okay, that's really interesting. Okay, so now let's say you're a medium to small manufacturer, for example, and you're not a Rolls-Royce of the world, and you now have this argument that it's secure enough to use, but what should someone who's trying to get an XR pilot off the ground in a manufacturing company do? What would you say should be their first steps, or your greatest advice, mistakes they shouldn't make early on? How can they prove ROI?
Christine, do you want to take that one?
Well, you know, it's thanks. I think it's very similar to the introduction of other new technologies into the manufacturing environment. You do have to look, it's a process. You start with the clearest, most urgent use cases. Now, in VR, your requirements are going to be different. With augmented reality, we're asking what information does that user need at the time when they're doing assembly or doing a task in the real world. So we're really focusing on those conditions when the human needs to make a decision, an informed decision, and they need that information on the spot. So I like to ask people to study the opportunities for AR in manufacturing along with their IoT or connected machines strategy. So if you already have networking to some of your machines, then let's start with those. Let's work at the information that those machines can produce and be seen by that human being in real time when they're in front of the machine. So we can start to create, we call a virtual interface to the machine. So that if there might have been in the old days, you know, some kind of a really cryptic small panel that you had to read with your magnifying glass, now the user can just walk up to an instrument in a factory and see its status in real time. So I like to talk to people about those kinds of use cases because it immediately expands the horizon and gets people thinking that their machines are connected, so should their people.
For me, I would agree. I think the number one driver for the adoption of the technology is the corporate or company culture. If you have the culture that's driven by improvement, if you have an Industry 4.0, a lean type improvement in culture, then XR will thrive in your environment. It just driven, from my perspective, you know, you talk about the 8 wastes in manufacturing from lean. I think that they always miss the 9th, which is knowledge management, the knowledge and the information that people require to do their jobs. I find that time and time again that when you draw out an organization, the problems are never in the boxes. If you draw out your organogram with the engineering, design, manufacture, service, etc., the boxes themselves are never the problem. They're improving constantly. It's the lines and the connections between them The use cases that we are seeing is allowing better management information. You've got the shop floor, getting information out of machines. It's a very much a one-to-one case. But getting that information back to base, getting that information back into the people to make the right decisions. We're seeing increasingly amounts of simple things like notifying when consumables are low, or just-in-time statuses and things like that. It's all about getting information into people's heads, and that's where manufacturing starts to exceed. When you start to get, into service environments where, engineers are trying to, repair machinery on a production line, but they're doing it at 3 o'clock in the morning, and they're doing it when they just want to get back to their bed, and they'll do the simplest thing to actually fulfill that, which is to fulfill the task and get out. If you're in a position where, through augmented reality or prior training in virtual reality, where you can put in their hands the optimum choice to actually A, get the job done as quickly as possible and get back to bed, or B, actually do the right thing to maximize the profitability and get the machine back up and running and get the reliability going. But again, I will draw back and just re-emphasize maybe the two key points for me is the culture of your organization and the information. A good way I would recommend every day, all day, in terms of these types of problems is organizations like the AMRC up in Sheffield. They are fantastic at engaging with you and helping you understand what your manufacturing problems are. And they've also got a really strong XR capability to turn around and say, actually, here's a solution for you. There's obviously companies like ourselves that will go in and actually build bespoke solutions for you. But again, I would say, and again, echoing what's been said previously, you can always find a golden hammer, but if your culture's not there, you won't actually deliver the benefit.
Appreciate the shout out to the
Completely
AMRC.
agree.
Oh, sorry. I appreciate the shout out to AMRC. They are one of Immersive's founders. They're fantastic. Rob Scott, especially at AMRC, is wonderful. I just want to quickly jump to a couple questions that are in the chat here.
But could I want to comment on the suggestion about corporate culture and the minds of people. We did a research project, I think 1.5 years ago, about AR in manufacturing. Specifically, what are the challenges, the obstacles that we still have to overcome for adoption?
Is this with the area?
Yes, it is.
Okay.
And that there's an executive summary available on the website to download. There's quite a lot of information. So, but to Frank's point, one of the key takeaways was the acceptance of the actual factory workers themselves to using this new technology. That was a major obstacle, was reservations about, I don't need to have someone tell me what to do. I know my job, you're breaking down my relationship with my job by introducing this new gimmicks and all these things I don't need. Just give me the tools that I have been using for decades, right? So there was a big divide between those who had performed a job for a long time and did not want to have technology interrupt their workflow versus the younger people who came into the workforce in a manufacturing environment who very much want to have AR and VR tools as part of their work environment because they've been using them, in their lives before coming to work. They have some exposure to this. The second thing I was going to say, you mentioned, Asha, that you asked a question about ROI, return on investment. We did another project, I think this one was in the end of 2017, early 2018. And we created a return on investment calculator. That was the research goal. And the calculator allows you to enter how many people, how much do those people cost you, what do you think the metrics are that you want to use. And then it produces you exactly, you found these links, perfect. So the ROI calculator in the spring of 2020, we made that a public resource. So we cleaned it up. We converted it from Excel to a web interface. And so you have to go in, and you do have a opportunity to add a lot of information. It's not industry specific, but it allows you to enter some information about your specific company, how much money costs you, the time when machines are down, how much can you tolerate that or not? And then it tells you, asks you questions about the cost structures and the cost of the equipment or the preparatory tools. And then it provides a number of months, weeks, in some cases, when you can reach a break even. So that's a really valuable tool for the industry, but not necessarily. It was developed for maintenance is the use case, but it's more generic than that now.
Thank you for the additional resources. I did pop them in the chat there if anybody wants to look either of those things up. So the question from the chat that I want to ask on behalf of Ned is, can you recommend any interface software to translate 3D CAD data for display via XR glasses for concept development, design reviews, installation aid of automation equipment? This ideally is suitable for remote collaboration so that people can connect from wherever in the world.
It's
a lot of options. Go ahead, Frank.
You know that you've just taken the words right out of my mouth. There's loads of options. Unfortunately, well, I don't want to talk just exclusively about Bloc, but we cheated. What we did is we took a lot of these tools and we put a machine learning governor on top of them, and actually would run them through in parallel and get best results. So we would know for what particular shapes, what tools would give the best outcomes. But what I would do is point, and I'm not sure it's been published yet, but the AMRC have performed a survey of all of these tools and evaluated them all. And so I think that's on the verge of being published. That should solve your problem about CAD crunching. In the meantime, the contact me. I can point you at various people, whatever you wish.
Yeah, I want to say about that subject. Our members decided in the spring of 2020 to do a research project about 3D model optimizations and the tool chain that you might use to prepare your models before bringing them into an AR environment. And I think that might be an additional perspective here is that the models that are made for the purpose of guiding machines and programming are not suitable for visualization and manipulation in real time. So these 3D CAD tools produce a variety of highly complex and highly detailed outputs, but you can't use that in all platforms. So having said that, we did do a pretty in-depth study, a very in-depth study of 8 different tools for model dissemination and processing. But I think it's really important to understand before you do any model manipulation or you choose a third-party tool to ask yourself, the tools that you're using today in your company may have plugins, or they may have already developed extensions for AR visualization. And I have found that to be the case in the most popular manufacturing CAD programs. So if you're using CATIA or you're using other platforms, for example, PTC, where a lot of design is done there, they already have, as part of their tool chain, an AR visualization engine and the whole back end and the front end too. So you may find that you don't need to look elsewhere, and that's already right in your wheelhouse.
That's great.
The one thing I will say with that, Christina, I agree. However, I would urge a little bit of caution there. some of those applications are extremely expensive. You know, that's one of the things that we're finding increasingly, that the cost again is one of the main drivers.
That's great. And I want to just give a quick shout out to Theorem Solutions, and Stephen Fletcher's written in the chat here about his solutions. Just someone answered that. And I know the chat won't be available for anyone who watches the recording after. Then another question, one thing I would ask you quickly, Frank, you mentioned that report by AMRC, you said it's not published yet?
I understand that, yes, that's the position that we're in at the moment. I think the publication was delayed slightly because of COVID.
Okay. Well, I am sure that we will also be promoting it once it's out. So follow the AMRC or Immerse, and you'll get that information soon. Another question here is asking, is it possible to view live IoT data of a machine while looking at it with an AR, with AR glasses or a tablet, for example?
Absolutely. It's the use case I was mentioning before. And I think it's really important for people to understand that it depends what kind of information. You don't necessarily need or want the raw data to be coming to the user in real time. We do need to have some level of interpretation, perhaps, because too much information isn't very helpful. But yes, absolutely. In many cases, you can get things like the production rates. You can get sensor data from, for example, the pressure or the other real-time conditions on the machines. So have you done any projects with IoT integration, Frank?
Yes, we've done some. We've got the general, as you say, what I would say production, the manufacturing type of solutions. We've worked with a number of different partners and customers in this area. Where our cutting edge, and I only say the cutting edge, Christine, here because I'm scratching my head trying to figure it out every day, is in test data. So we are taking large bursts of data where we're actually trying to consolidate that and visualize it. Examples that I can talk about are, we work with the University of Leicester, the space park, where they will have shaker tables providing, testing if a satellite will actually survive launch. And so, but the issue they have is they can't get everyone into the lab anymore due to COVID. So we're working with them to try and stream that data real time back to people who are remote. I will say we are near real time.
Space data?
Sorry?
Like data from space?
No. Sorry. When you launch a satellite, the rocket's quite a violent experience. So what they do before the rocket is they launch it, is they simulate it on a shaker table where they put the satellite on and vibrate it. And so that data, we get about 2 million data points. So about 1 million data points a minute we get. And so we're actually working extremely hard using distributed streaming technology to merge that. We are about 7 to 1 at the moment. It's taken us 7 minutes to process a minute's worth of data, but we've actually got some new kit and it's halving that. So again, it's one of those ones where the hardware limitations are being overcome constantly.
Right, and I think you highlighted exactly the point I was trying to make, which is that too much data is difficult for a human to process. It's impossible. Even a computer can't process it. So the examples I've seen are in textiles and weaving. I've seen some examples in food processing. So they need to know the temperatures. They need to know, how long a particular process has been ongoing. What are some other things? Oil and gas, that's not a manufacturing use case, but when people go to a facility, they need to be able to see what the status is. When was the machine last maintained? That's quite lightweight data. It's not changing every milliseconds or faster. so the sample of information can be much slower than than vibrations on a spaceship. So you'll be looking for things like pressure or speed or temperatures, things that are relatively intuitive for people to understand, but hard to get that information from the outside of the machine. So there are, I think, connected factories and connected instruments can go beyond just the machine itself, but also the instruments that one uses to repair or maintain your capacity. Frank, you've seen some instrumented, connected instruments.
Very, very much so. Very much so. Sorry, Asha, can I cheat a little bit, because there's a question there I just popped up about universities. I think this is one of the areas.
Yeah, it's just, sorry, I'll read it just for the recording. It says, what role do you see for universities in developing XR for use in manufacturing?
So I think that this type of suggestion of, it's not just a pure software engineering task. It's about, Christine, to your point, we take this huge amount of data and we actually turn it into a pattern, and people can recognize the patterns and they can interpret the information in that way. It's very much around the status at a glance. You want to be able to stop the snowball of failure before it turns into an avalanche. And so that's where the early stage patterns, as you say, temperature flagging up, you get the red light, you get the amber light, whatever. It's how we're very, very good as human beings in spotting these patterns. And so getting that information, consolidating it and putting it out. And again, we work closely with the universities of Leicester and University of Derby, Cranfield also, and we did some work with CERN. Well, the university did some work with CERN. We were in on the outskirts, outside of that, advising, but they were looking at the Large Hadron Collider and how to consolidate and visualize 3 terabytes of data a second. So, we had to admit that was probably not an XR solution at this point. But again, this is the roles that the universities can play, is how to interpret and visualize data.
Right. So I'm also involved very closely with technology transfer, and in addition, I mean, technology transfer is what you get to do after the research has reached a certain level of maturity. Now, for the last few years, what I've been working on with area members and in the context of the research committee that I chair is what I call the research agenda. And what we're trying to do is help those who are in faculty positions, as well as those who are in funding positions, research funding, to focus in on those parts of the problem that have received the least attention to date, but could have the greatest impact if we could solve some problems. So, what we've done is a very interesting analysis of all the scientific publications pertaining to augmented reality for the last 3 years. That's about something on the order of 5,800 publications. And that from that, we took the keywords that the authors had provided and did a scatter analysis of visualization of the words that the authors had provided. And we very quickly came up and could see there are topics where there's great focus and attention, things like machine learning, artificial intelligence, computer vision. But there also are some real gaps. There are places where nobody seems to be looking at this. Things like in the human interface. So visualization, how big, how bright, how long, these kinds of things are not studied in a quantitative way at this time, and they need to be if we're going to provide these technologies safely and cost effectively. But there's many, many other important gaps. One of the ones that have I discussed just a few minutes ago is interoperability. So right now, it's hard for a business to take 2, 5, 10 off-the-shelf products and integrate them into a solution that works for their company. And we need to have interoperability standards to make that happen more cost effectively and just with less risk and loss of time. So I think that's another area that universities need to get more involved in implementing their theories into real world standards that people can adopt.
It's really interesting. Actually, if there are any people in education who would be interested in getting involved in standards work, probably reach out to any of us. Probably Frank, you're probably involved in some as well, but I am also involved in some stuff with the BSI. Christine, I know you are as well. So probably good to reach out so that, it's always good to know where different stuff is going on and we can signpost people to getting involved if they'd like to be. Just in the interest of time, because we're down to our last few minutes, I just want to send a little bit more information out about manufacturing made smarter. I'm sure everyone on this call probably knows about it if you're already in the manufacturing sector, but my KTN colleagues on the manufacturing team do a lot of work around this, and it's a lot of money that's coming out from the government to try and help the manufacturing sector with their digital transformation journey. That's the very short synopsis of it. There'll be lots of different calls coming out. I'm going to signpost you with some email addresses to the manufacturing team in case you have further questions about that, and to an event for a briefing session that's coming up shortly. But I know that VR and AR is one of the 5 technology sectors that they're most interested in supporting with this part of the Industrial Strategy Challenge Fund. So keep your eyes peeled for future opportunities. And on that note, we only have a couple of minutes left. Oh, and yeah, we'll send all of these links, by the way, and everything in a follow-up email, just so you know. I'm going to let you, Christine and Frank, just give your final thoughts before we sign off. So Christine, do you want to start? Any last words of wisdom or advice for everyone?
Join the area.
And immerse.
Shameless plug.
Yeah.
No, but all kidding aside, it is a very, very valuable organization. The AMRC is a member, as is the Manufacturing Research Center, the MTC. Thank you. I think that it's important to think broadly about manufacturing, that it's not just heavy manufacturing. There's also very, very exciting opportunities to in related fields. And I think that's going to be interesting to see how we use AR in smaller businesses and smaller facilities. It's not for today, but it's coming.
Fantastic. And Frank?
From my perspective, start simple. Keep it simple. Make sure that you can get a good return of investment in your initial activities, and it will grow from there, and it will benefit. We've seen time and time again that the application of these technologies, as well as the information management that goes with it, they deliver significant returns of investment.
Fantastic. Thank you both so much for your time today. Really, really appreciate it. And thank you to everyone who joined us.
Pleasure.
Absolutely. I'm really blown away by how much you managed to fit into an hour. It's a very, very big topic. So I really appreciate that. We're going to send, Anita, our events manager, is going to follow up with an email just with all of the links and extra resources that we've been kind of talking about. And thank you all for joining us. Have a great evening.
Thank you. Bye-bye.
Thanks, guys.
Bye-bye now.